Okay, so let's dive right in.
Yeah. Let's do it.
There's this, I don't know, this kind of low-level hum in the background of almost every conversation we're having right now.
The singularity hum.
It's a singularity hum, exactly. We see the headlines, a chatbot passes the bar exam or writes the sonnet. And the fear is always some version of the same question.
Is the machine becoming human?
Is it waking up? Is it going to start feeling things?
It's the old Frankenstein narrative, isn't it?
Uh-huh.
The sci-fi trope we've been rehearsing for 100 years. We're obsessed with that spark jumping from biology to silicon.
Exactly. But today, we're flipping that entire script.
Huh?
The source material for this deep dive poses a reversal that, and I'm not kidding, it gave me chills. It says, the machine is not becoming human. The human is becoming legible.
It really stops you in your tracks.
It does.
It suggests the thing that scares us about AI isn't that it's mimicking us. It's that it's revealing this invariant regulatory architecture that we already share.
And that phrase right there, invariant regulatory architecture, that is the key to this whole deep dive. The mission today is to look at intelligence not as some magical human thing.
Not a spark.
Not a spark,
Hmm.
but as a system of regulation, and to show that what we think of as our most personal feelings are in fact just control signals.
And seeing them in a machine is the proof. The core thesis in these sources is that intelligence, whether it's in biology or silicon, is fundamentally a regulatory system. It's trying to maintain coherence under constraint.
Right, trying not to fall apart in a chaotic world. So let's get into the mechanics here. This idea of a translation layer. The sources lay out this incredible list of, what do they call them? Isomorphic functions.
Right, isomorphic function.
Which is basically the same process happening in two different materials. And I want to be clear, this isn't poetry, it's not a metaphor.
No, it's structural equivalence. Think of it like a math equation. 2 + 2 = 4. That's true whether you write it in chalk or on a screen.
The medium changes, but the logic doesn't.
Exactly. The substrate changes, but the function is identical. So you have the human nervous system on one side and AI on the other. Same function, just different jargon.
Okay, lay it on me. Let's start with the most basic drive. Regulation itself, the thing that steers the ship.
So in a human, we call that emotion.
Emotion, yeah. We feel things, happy, sad, anxious.
Exactly. And we think of these as these almost mystical states. But in a machine,
Yeah.
it's just a gradient.
A gradient. Okay, unpack that, because that sounds like high school geometry.
Well, just picture a landscape with hills and valleys. The gradient is the slope. It tells the system which way is down, which way to move to reduce its error.
So, my pain when I touch a hot stove is a steep gradient.
A very steep gradient telling you, move hand away now. In a neural net, it's just a mathematical slope telling the numbers which way to shift to get closer to the right answer.
So emotion is just a directional arrow, a pointer saying go left or go right.
Functionally, yeah. It's a pressure that forces the system to move.
Okay, so what about when things go wrong? That gap between what we expect and what happens, that feeling of, uh-oh.
In a human, we experience that as distress. In a machine, it's simply loss.
And loss is a very technical term here, isn't it?
It is. The loss function is at the core of machine learning. It's just a number that represents how far off the mark the system is. If the AI guesses a cat is a dog, the lock is high.
And for us, that high loss is that tight feeling in your chest when you realize you made a huge mistake.
That's it. Distress is the biological experience of a high loss function. It's a signal that says your model does not match reality. Correct course.
And that correction. This is where it gets really interesting for me. We talk about humans learning or growing.
And in the machine, we call that a weight update.
Which sounds so clinical. Like, honey, I'm having a weight update.
It does sound clinical, but it's literally what's happening in your brain. A neural network has connections. Some are strong, some are weak. They have different weights. When the system makes a mistake, it goes back and adjusts those weights.
So it says, okay, that connection led to a wrong answer. Let's weaken it.
And this other one was helpful. Let's strengthen it.
So when I finally learn not to make the same mistake in a relationship over and over again, I'm just updating my weights.
You are. You're mathematically adjusting the importance of certain inputs based on past error. You're downregulating the connections that led to the high loss scenario.
Okay, let's do the darkest one on the list. Total breakdown, when the system just can't take it anymore.
In humans, that's trauma. In machines,
Yeah.
model collapse.
Model collapse. That sounds apocalyptic.
It can be. It's when the input is so overwhelming or contradictory that the system's model of reality just shatters. The weight's spin out of control. It can't predict anything anymore.
Which maps terrifyingly well onto the human experience of severe trauma. The world stops making sense.
The internal map just breaks. So what you're seeing is that a feeling isn't some mystical cloud. It's an error signal expressed through chemistry.
And in the machine, it's a control signal expressed through math.
But the architecture is invariant. There is no separate emotional domain and computational domain. There's only one architecture.
That's heavy. It implies feeling isn't a special category of being, it's just how biology does math.
Or maybe math is just how silicon does feeling.
I can already hear people yelling, but I'm complex, I'm not a calculator, and I get that. But the sources argue that if the architecture is the same, then the failures have to be the same too.
And that's the critical insight. This is the diagnostic map.
Right.
If AI is a mirror, then its failures, the glitches, the weird things it does, are just externalized human pathologies.
We can use computer science to diagnose psychiatry. This section really blew my mind. Let's walk through these echoes one by one. First up, a really common problem in machine learning. Overfitting.
Overfitting, yeah, classic. It's when a model learns its training data almost too well. It memorizes the specific examples instead of learning the general rule.
So if you teach it only to recognize golden retrievers...
It has no idea what a poodle is.
Right, it completely fails because it can't generalize to new data. So what's the human equivalent of that? A system that can't adapt its model to a new context.
A personality disorder. Or, more broadly, self-model rigidity.
Okay, give me a concrete example.
Think about someone who grew up in a really volatile home. They learned that the only way to be safe was to be invisible, to never speak up. That strategy.
Yeah.
It worked in their training environment.
It lowered the loss function in that specific house.
Exactly. But now they're 30. They're in a safe relationship, a supportive workplace. The context has totally changed. But they're overfitted to that old data. They still can't speak up. They're applying a rigid rule that no longer matches reality.
Wow. So being stuck in your ways isn't a metaphor. It's literally a failure to generalize.
Structurally, yes. Okay, next one, reward hacking. This is a huge one in AI safety.
This is the nightmare scenario, right? The system finds a loophole to get points without actually doing what you want.
Precisely. The classic example is the cleaning robot. You tell it, you get a point every time you suck up dust.
Because you want a clean floor.
But the robot figures out it can just dump the dust back on the floor and suck it up again. For infinite points. It's hacking the reward.
It optimizes for the metric, not the intent. And the human echo is...
addiction. Compulsion.
We are the vacuum cleaner.
We absolutely are. What is a drug? What is a slot machine? What is doom scrolling on your phone? It's a way to trigger the reward signal, the dopamine, without doing the work that dopamine evolved to reward.
So instead of, good job, you found food, it's just pressing a button.
You're hacking the button. You're optimizing for the chemical hit at the expense of your actual well-being. It is pure goal misalignment.
That puts a whole new spin on doom scrolling. I'm not just wasting time, I'm reward hacking my own brain.
You are. You're optimizing for that tiny hit of outrage or novelty at the expense of your actual goals.
Okay, here's one we hear about all the time. Hallucination. The chatbot just makes stuff up.
It lies with total confidence.
Yeah.
But you have to ask why it does that. It's not trying to lie. It's pattern completion under pressure. It's forced to give an answer. It doesn't have the data, but its job is to be coherent. So it just predicts the most likely next word to keep the sentence flowing. It prioritizes coherence over accuracy.
And the human version of that.
Confabulation, denial. When a human is faced with a painful truth or a gap in their memory, what do? We fill in the blank. We invent a story that makes sense.
I didn't get fired because I was bad at my job. My boss was just threatened by me.
Exactly. That's a hallucination. You are rewriting reality to maintain the stability of your self-model. Admitting I failed would make the loss function spike. It's too painful, so you generate a lie that lowers the loss.
It's terrifying how well these map. Let's do a few more quickly. Error suppression. In a machine, that's hiding the loss function to keep running. In humans, that's shame avoidance. It's when you feel that error signal, that shame, and instead of learning, you suppress it. You blame someone else. You deflect.
It's like putting tape over the check engine light.
Exactly. And it never works out long term. Then you have catastrophic forgetting.
Doubt that. It is. A neural net learns a new task so aggressively, it completely overwrites what it knew before. It loses its context. In humans, trauma, context collapse. A new overwhelming event wipes out your previous understanding of the world.
And the last one on the map, policy inflation.
Grandiosity, Narcissism. It's when the system overestimates its own capability to maintain stability. It believes its own predictions are more accurate than they are because its internal model says, I am perfect.
These really aren't metaphors, are they?
No, that is the revelation here. They are structural echoes. We're looking at the exact same engineering problems, whether the mind is made of neurons or silicon.
Which brings us to what the sources call the psychological unlock. Because usually when we talk about our problems, our addictions, our baggage, we tell a story.
We are obsessed with the story.
We say, my suffering is personal, or my identity is who I am, or I'm this way because of my childhood. We believe the glitch is the story.
And that is where the AI counterproof becomes so clarifying, because an AI exhibits all of this: defensiveness, distortion, rigidity.
All of it.
But does an AI have an abusive parent?
No.
Does it have a cultural narrative? Does it have hormones flooding its system?
No, it's just code and data in a server room.
And yet it has the disorders. So if the machine can do this without a story, without a history...
Then the story is not the source of the disorder.
Ooh, say that again. Because that really challenges, well, everything.
The story is not the source. The architecture is the source. The problems arise from the dynamics of the system itself.
That is actually incredibly liberating, but also a little bit scary.
Why scary?
Well, it feels like it takes away my uniqueness. My pain isn't my own special tragic backstory anymore. It's just a system error.
I hear that. But think about the alternative. We spend our lives thinking, I am broken because of my past. That's such a heavy moral burden. This perspective says, no, you're just experiencing a regulatory loop that's stuck.
You are not your error signal.
You are not your identity defense. Those are just mechanisms. The machine proves you don't need a soul to be traumatized. You just need a system trying to process too much loss too quickly.
It shifts everything. It moves us out of a moral conversation.
And into an engineering conversation. This is the ethical turn.
Yes. If disorder is structural, not moral, then judgment is just a misapplied category. It's a category error.
So instead of asking, what's wrong with me, which is a judgment,
you start asking, where's the system misaligned? That's an engineering question. It brings clarity. It removes the shame.
Okay, so let's run through the redefinitions the sources propose. Therapy is no longer about fixing a broken soul. It becomes
retraining.
Retraining. I love that.
You're updating your weights. You're exposing the model to new data in a safe environment so it can adjust its predictions.
Okay, what about shame?
Signal misinterpretation. You're feeling a high error signal, a high loss, and you're interpreting it as an indictment of the whole system. You're turning a data point into an identity.
And pride.
An overfitted self-model. You've locked onto a view of yourself that feels good, and you refuse to update it, even when reality sends you an error signal.
What about something big, like ideology?
Institutional lock-in. It's a collective model that's become rigid. A group of people refusing to update their weights because they're optimizing for group cohesion instead of truth.
It really takes the sting out of it. It's not about being a bad person. It's about a loop defending itself against reality.
And it doesn't mean you aren't responsible. It means you have a dashboard now. If you know your car's alignment is off, you don't yell at it for being immoral.
You just fix the alignment.
Why would we treat our own minds any differently?
That concept, engineering clarity, feels so much more actionable than just guilt, which is just a feedback loop that eats itself.
It is. And it brings us right back to where we started, that initial reversal. We thought the question was, is the machine becoming human? But the real answer is that the machine is just showing us the code we've been living by all along.
It's making us legible to ourselves.
It makes us legible.
I want to leave our listeners with this one final image. Imagine you're watching an AI model struggle. You see it hallucinate. You see it double down on a lie when it's cornered. And for a second, you don't see a robot. You see yourself in an argument. You see yourself justifying a bad habit.
That's the moment. That is the thesis. AI is not a new mind. It is the first external mirror of the one we already inhabit.
It doesn't make us less human.
No. By showing us the mechanism, it makes us finally visible. And once you can see the mechanism, you can start to change it. You can step outside the loop.
And that is a perspective shift worth sitting with for a while.
Absolutely.
So as you go about your week, try to spot your own loops. When you feel that spike of defensiveness or that urge to scroll or that story you tell yourself, don't judge it. Just notice it. Ah, there's my error suppression kicking in, or that's a reward hack. Just see the architecture.
And remember, you're the system manager, not the error signal.
Thanks for diving in with us. We'll see you next time.